Good day, physics. I miss you guys, my students. I hope you're all doing well. So this week I'm going to do a little different. As you can see, I'm talking to you. I'm talking to you using this presenter board that I used to use in class anyway, and we're going to make it feel just like a regular class. So to give you a break from reading and listening and taking notes from other people, I'm going to kind of recommend that you take notes on this video, highlighting the next slide we're going to look at. Take a picture, not of the screen and submit that, but handwrite your own notes, because you're going to need those for the problem solving exercise I'm going to give you on Tuesday. So make sure you can do those. Make sure you have good notes. If you don't have good notes, you're not going to do well on Tuesday or Wednesday's assignment. And don't forget, if you don't understand something, you could always send me a private commentary. Alright, so this is a brief look at what we're doing this week. We're taking notes today. Tomorrow we're doing problem solving, and Wednesday we're doing using this information to solve a real life problem. Moving on. So these are the equations for power for this chapter. I'd like to start off with saying that a lot of you found a lot of these notes all on your own. You figured out that power is work over time, or basically that means how fast you can do work. And we measure work in watts, represented with a capital W. So there are basically three versions of this power equation. All of these are listed here. Power is either current times voltage, power is either voltage squared divided by resistance, or power is current squared multiplied by resistance. We can manipulate these three basic equations, whether it's the black one, the blue one, or the purple one, to solve any one of these problems here. We can rearrange this equation to solve for current. We can rearrange this equation and solve it for voltage. We can do the same thing with this equation here. And you're going to need these to be able to solve this week's problem. This week is probably the most challenging work that I've given you since I've seen you in class. Hence why I'm taking the time to explain these things to you. So let's move on next to some problem solving. Aha, these are the sheets that I used to give you guys in class. I'm sure you guys are all choked up that you're looking at this right now. You miss it. You miss my class. You miss my jokes. And, well, I have to keep it light because, there's no plausible deniability here. So anyhow, let's move on to problem solving. So we're going to do problem number 26. It says, what is the power consumption of a light bulb that draws a current of 0.5 amps when connected across 120 volts? The first time you read it, you'll probably get a little cross-eyed not knowing what all those things mean. Let's break it down. So first thing is, what are we looking for? What is the power? So that makes P my question mark. And then it says we draw a current of 0.5 amps. So my current is 0.5 amps. And 120 V, well, that's my voltage. 120 voltage. So if you have good notes from the last slide that I just showed you and talked really quickly about, you're going to know that you're going to use this equation. P equals I times V. So here you're going to do 0.5 multiplied by 120, and you're going to get 60 watts. You don't even need a calculator if you're pretty good. I won't, hold it against you if you have to use a calculator, but that's okay. All right, so let's move on. Now, one thing I want to reiterate, if you're doing problems and you ever have issues with the homework, you should post your comments on the actual assignment when you open up the assignment. That way it's only me who's reading the assignment, your question. Some of you have made posts on where the actual assignment is, and that kind of gets broadcast to everybody. Doesn't matter either or. I try to keep it, well, I don't know. I try to keep it something. All right, but let's take a look. The next problem says, find the power. If you read the problem, a toy car's electric motor has a resistance of 17 ohms. Find the power if it's delivered by a 6-volt battery. So, once again, power is the question mark. but this time we have a resistance of 17 ohms, and we have a voltage of 6 volts. So if we look at our magical cheat sheet, this time we're going to use this equation. P is equal to V squared over R. And so now it's just a matter of plugging in numbers. These problems so far are easy. Just plug and chug. But as you guys know me, nothing's ever easy with me like that. So I will find new ways to make sure you took good notes on that last slide. So now I take out my calculator, I do 6 squared, I remember the PEMDAS rules, and then I divide it by 17, and I get the magic number of 2.12, and that would be watts. That would be my answer that I got. Okay, moving on to the next problem, number 28. This particular problem says a 9.6 amp electric current flows through an electric oven with a resistance of 25 ohms. What is the power dissipated in the oven? Once again, we're looking for power. This time, we're given a current of 9.6 amps, and we're given a resistance of 25 ohms. So we're going to use the third iteration of the power equation. And so here we're going to do 9.6 squared. Do that first under the PEMDAS rules, and then we're going to multiply that by 25. If I wrote everything right in my calculator, I'm going to get the following answer, which is 2,304 watts as my answer. Moving right along, number 29. Off the screen there. All right, number 29 says when 12 volts is applied across a resistor, it generates 350 watts of heat. What is the magnitude of the resistance? Now, don't let this one trick you. It doesn't clearly specify a lot of things, and you might get confused by some of the numbers. First off, the question. We always look for the who, what, when, where, in this case the what. What is the magnitude of the resistance? So R is what I'm looking for. 12 volts. V, that's voltage. 12 volts. And 350 watts, well, that's power. Okay, so if I were to look at my equations, I'm going to use this one. P is equal to V squared over R. And this is one of those cases like I've been preaching to you since day one of school. These two guys are going to cross multiply. They're going to basically switch spots. And so my equation is going to become R is equal to V squared over P. I can plug in my numbers, 12 squared divided by 350. Don't forget to do the squared first. Plugging it into my calculator, I get the magic number of 0.41, and that would be ohms. Almost done. 2 more problems to do. All right, moving on to problem number 30. This time we have a 30 ohm toaster. We need to recognize ohms, that's that omega symbol, as resistance. So we're going to label that as resistance. 30 ohms. Consumes 560 watts of power. So we have 560 watts of power. How much current is flowing through the toaster? Current is my question mark. So if I took good notes on that second yellow slide that looked like notebook paper, I would probably look, since I have resistance, power, and current, I would start looking at this column, which says P equals I squared times R. If I rearrange this equation, I would divide both sides by R and then take the square root, so the current becomes the square root of P divided by R. I can plug in my numbers now. 560 divided by 30, take the square root of that. So and lo and behold, I get the magic number of 4.32 amps. All right, moving right along. How much voltage must be applied across a 45 ohm little light bulb filament in order for it to consume 75 watts of power? So voltage is my question mark. Resistance is 45 ohms. And power is 75 watts. So I have to look at which equations deal with voltage, resistance, and power, which would be this one. Power is equal to V squared over R. Solving this for V, I would first multiply both sides by R and then take the square root. So V is equal to the square root of P times R. Plugging these numbers into my calculator, I would take the square root of 45 times 75. And I get the magical answer of 58, I'm going to say 0.1 volts is my final answer. Okay, so don't forget, today what I want from you is I would like for you to take a picture of the notes that you took. If you are clever, you will have written your notes. Don't take a picture of the screen and send it to me as your notes. Those aren't your notes. You need to write down the notes from the yellow slide where I talked about all the different variations. The three equations that are three basic equations and all the different variations. Remember, this will probably be the most challenging assignment you'll have. You can use this video to refresh your recollection on how to solve for problems. Good luck, and I'll see you all soon.